cumulative binomial probability tables. Question 1 part A, we have a binomial distribution, n is 10 trials, probability of success in any one trial is 0.4. So you might see this in a question, work out the probability of at least 8 successes. So that means more than or equal to 8. So more than or equal to 8 means out of 10 trials, the number of successes could be anywhere between 0 and 10, but we're specifically told we want more than or equal to 8. So 8 or more, this is what we're after. But more than or equal to 8, you can't use the formula book and the tables with that, because the tables are cumulative. What you can do from the tables is look up less than or equal to 7. And what this is demonstrating is that you've got the probability x equals 0, the probability x equals 1, x equals 2, x equals 3, all the way up to the probability x equals 10. And if you add them all together, I mean that is like the sample space, they add up to 1. So what we're going to do is we're going to work out this side from the formula book. And this is px less than or equal to 7, right here. So we go to the formula book for this cumulative probability. We do 1 minus, and that will give us the probability of this region, which is what we're after. And that's how you use the formula book. Part B, same binomial distribution. We're looking for at least 5 successes out of those 10 trials. So this is what we're after, x greater than 5. So greater than 5, these values. So again, we can use the formula book to look up less than or equal to 5. So this region will come from the formula book, px less than or equal to 5, this part. All of these probabilities add up to 1. So 1 minus less than or equal to 5, there, will give us the region that we're after. Part C, so we're looking for fewer than 7 successes, so x less than 7, which means we're after these values, not including the 7. So less than or equal to 6, we go to the tables and we look up our probability. No need to do any 1 minus something this time. Part D, between 4 and 8 inclusive. The inclusive means we want the 4 and we want the 8 as well. So we're after these probabilities. Now if we do px less than or equal to 8, that includes every probability from 0 all the way up to and including 8. So I'm just going to highlight underneath. It includes all of these. Now we don't want all of these. We need to get rid of the 0, 1, 2 and 3. So we subtract this region off. And what you're left with is the section in green, which is what we're after. Part E, between 4 and 8 successes. This time the 4 and the 8 are not included. This is what we're after. So x greater than 4, so that's going to be 5, 6, all the way up to 7. X less than 8, the 8 is not included. So if we look up less than or equal to 7, that's every probability here. This is from 0 all the way up to and including 7 that's included in this. And we don't want all of them. We don't want the 0, the 1, 2, 3 or 4, so less than or equal to 4 is subtracted off, leaving us with just the 5, 6, 7, which is what we're after.